today we're going to start looking at electron configuration, which basically is just how the electrons are configured around the nucleus of the atom. Remember, the early models had the electrons shown like in orbits around the nucleus of the atom, almost like cars going around a racetrack or planets in orbit around the sun. And to a degree, that's kind of true, but it evolved over time to be that the electrons are out there in this electron cloud. So there's areas where they are more likely to be. We're going to simplify it somewhat, because if you go out there and Google orbitals, SPDF orbitals, you're going to see that where the electrons are found can become very, very complex with these different orbitals. So we're going to try and simplify that as much as possible, but to kind of get an idea to see how the electrons are configured around the nucleus of the atom. So I've sort of devised this little diagram to help us place the place the electrons in their specific orbitals. So we're going to follow this through. It's almost like a game of chutes and ladders. If you want to think of it that way, it's kind of like a puzzle in another way. But there are just some rules that we need to sort of go by. So first of all, the numbers here, these rows are representing the energy levels that go outward from the nucleus of the atom. And then these columns, you'll notice that are S, P, D, and F, represent the orbitals where you find the electrons. So for now, we're not going to worry too much about the numbers. We'll come back and talk about that later. We're going to add a little bit to this each day. So today I just want to talk about the first step in placing the electrons. Here's what you need to know. Any box in this first column can only have up to 2 electrons. So anything in the S column or in the S orbital can only have up to 2 electrons. For the P orbital, you can have anything up to 6. For the D, anything up to 10. And for the F, anything up to 14. So those are the maximum numbers of electrons that we're allowed to place in the boxes within each of those columns. So you might want to jot that down somewhere to come back for reference. So S is 2, P is 6, D is 10, and F is 14. Then what you do is you look at how many electrons you need to place. And if you remember, going back to the periodic table, the atomic number tells you the number of protons. Protons equals the number of electrons. So that's how we find the number of electrons that we have to place for each one of these elements. And then we just begin filling from the bottom up, making sure that we follow these arrows that I have put on. So let's say, for example, let's go to our periodic table. Let's find, let's do oxygen. So when we look at oxygen, the atomic number is 8, which tells us that there are 8 protons. And from that, we also know then that there would be 8 electrons. So we come back to our chart, and let's write that at the bottom. So let's say that we are going to work with oxygen. Whoops. And the symbol for oxygen is O. And we know that the atomic number is 8. So that means we have 8 electrons that we need to fill in on our chart. So we're going to start with the first arrow. And of those 8 electrons, how many can we put in this box? 2. So we place 2 electrons in the first box. We now have 6 more electrons that we have to place. We go to the next arrow, start at the bottom, work our way up. So this box is where we go next. And of those 6 electrons we have left to place, we can put how many? 2. We've now placed 4 of the 8 electrons. That means we have 4 electrons left. We go to the next arrow, come to the bottom, work our way up, This is the first box we come to. We have 4 electrons left to place. We can put up to 6 in any of these boxes, so those 4 will fit. And we're done placing our electrons. We needed to place 8 electrons. So we put 2, 2, and 4. Let me erase those out. Whoops. I guess I didn't need to get rid of those. And let's do another one. Let's go back to our periodic table. Let's do titanium. Titanium is 22 on the periodic table. Let's go back to our chart. We're going to do titanium. Which is Ti, and its atomic number is 22. So that means that we need to place 22 electrons on our chart following our rules. Remember again, S can get up to 2, P can get up to 6, D can get 10, and F can get 14. We need to place 22. So we start at the first arrow, first box, we put 2. We have 20 left to go. We go to the next arrow, this box is next, we put 2. We've now placed 4. We go to the next arrow, start at the bottom to work our way up. We can put 6. So we have now placed 2, plus 2 is 4, plus 6 is 10. We have 12 more to go to get to our 22. Keep following our arrow up, and we can put 2 there. We've now placed 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. We have 10 more to place. Go to the next arrow, work our way up. Of the 10 we have left to place, we can only put 6 in this box. So let's add up to see how many we've got. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18. So we have 19, 20, we have 4 more to go. Can we put 4 in this box? No, we can only put 2, which means that we have 2 left to place. Go to the next arrow, come to the bottom, work our way up. The 2 remaining electrons can fit easily in this box because it can hold up to 10. So let's double check to make sure. We have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, 22. So this is how you fill in the numbers, and this is the first step in the electron configuration. You find the atomic number for the element that you're trying to fill in. You come to the box, follow the arrows from the bottom to the top, and just fill in the boxes as you go. You can only put anything up to 2 in this column, up to 6 in this one, up to 10, and up to 14. We will talk about these lines in the next step. All right, so if you will go back into Canvas, I have an assignment there with links for each class. Click on that link. That will take you to a Pear Deck. And on that Pear Deck, there will be 10 slides with 10 different elements for you to begin working on the electron configurations for those. Go shoot for the first 5. You don't have to do all 10 of them. Just kind of practice and see if you're getting the hang of it. Come back and look at this video again if you need a refresher. But again, just remember that the 2 rules are that you have to follow the arrows from bottom to top, put in your numbers, adding them along the way until you get to the atomic number. You can only put up to 2 in the s orbital, up to 6 in the p orbital, up to 10 in the d orbital, and up to 14 in the f. All right, practice at least those first 5 in the pair deck. Let me know if you have any questions. And as I see you this week, we will continue to work on these. Have a great day.